Hello everyone, I welcome you all to today's discussion session wherein we are going to discuss the CAT 23 paper, the slot 2 paper particularly, CAT 23 slot 2 paper, the QA section. So as you all know, we had 22 questions. Next, 14th one. A container has 40 liters of milk, then 4 liters are removed from the container and replaced with 4 liters of water. So here we are replacing the contents of vessel with water. Whenever that happens, there is something that always holds true. Whenever such kind of replacement happens, we can write the following equation. The replacement rate, the percentage. Say for example here, from 40 liters we are replacing 4 liters. That means we are replacing 10% of the solution. So replacement rate will be 10%. So whatever is the replacement rate, that will be equal to the percentage drop in concentration. So for example, if I replace 5% of the solution, the concentration of milk, in this case milk, will drop by 5%. If I replace 10%, the concentration will drop by 10%. If I replace X% in general, concentration will drop by X%. Reverse is also true. For example, after this kind of iteration, suppose the concentration of milk dropped by 15%, that would indirectly mean I have replaced 15% of the solution. So here in this case, I know the replacement rate is 10%. So that means the percentage drop in concentration will also be 10% each time you do it. This process of replacing 4 liters of liquid in the container with an equal volume of water is continued repeatedly. The smallest number of times of doing this process, after which the volume of milk in the container becomes less than that of water. See, he's asking us minimum number of times that I need to repeat this process so that the volume of milk becomes less than the volume of water. That indirectly means the concentration of milk should become less than 50% or not. Because if concentration is 50%, that means half of the solution is milk, half of it is water. They are equal. But I want milk to drop below this half. So concentration should go below 50%, isn't it? So let's try to do it manually. Initially it was milk, 100% milk. After one iteration, what will happen? There will be 10% drop. So I want to check when does this percentage fall below 50. The first time it does, that is my answer. So many iterations will be required. So one time it will become 10% less, 90%. Second time this will become 10% less. What is 10% of 90? 9. It will drop by 9. Let's do it slowly. Third time this will drop by 10%. 10% of this is 8.1. Decrease it, it will become 72.9%. Still it is much more than 50. Next, fourth time, 10% of this is 7.29, approximately 7.3 you may say. So if you drop it by 7.3, approximately 65.6. Still not less than 50. We have to go for fifth time. 10% of this is 6.56. So something like 6.6, approximately 6.6. So it will become what? 6.6, 59 approximately. Still not less than 50. You have to go for sixth time. So 10% of this is what? 5.9, approximately 6. So 53.1%. Still not less than 50. So that means even after repeating this process for 6 times, I see that concentration of milk is not dropping below 50%, and hence volume of milk will not be less than volume of water. So that means we'll have to go for one more time. What is 10% of this? It is 5.3 approximately. So when you drop it by 5.3, how much do we get? 47.8, and this is the first time it has gone below 50%. And thus can I say the smallest number of iterations that we need to do here is simply add these arrows. So when you add them all, you'll get 7 as your answer. So you could do it manually like this. I hope this was clear. So if you are clear with this concept, which we have discussed in the classes, alright, we would have learned it in the classes in your textbook. We can use this concept and manually get to the answer.